Hello friends, I hope you all are doing great. So today we will be starting with chapter 3, that is metals and non-metals. So first of all, let's start with metals. So what is a metal? We all must have heard this common term metal and non-metals. So have you ever wondered what actually metal is? So first of all, let us dive deep into this technical definition of metals. So according to this definition, a metal is a substance that has a lustrous appearance, that is, it has a shiny appearance, is malleable and ductile, and conducts heat and electricity. So, a very famous example of a metal which is used as a conductor is copper. You must have seen wires, and when they have a plastic covering over them. So when we unwrap them, we find a copper wire. So this proves that metal is a very good conductor. Metals are very good conductor of heat and electricity. And metals have high melting points and boiling points. That is, if we want to melt any metal, we have to melt them at a very high temperature, and same as for the boiling. Now, non-metals. Non-metals are almost opposite of metals. They possess almost opposite properties as possessed by metals. So, a non-metal does not have the properties like malleability, ductility, hardness. I'll explain about these terms later. What is malleable, ductile, and hardness is we all know what hardness is. So that is it can be pressed easily. Non-metals can be they can be pressed easily, whereas in the case of metals they cannot be pressed easily. So they are hard in nature. Whereas non-metals are brittle, that is, they can be broken down easily, and non-metals are not good conductors of heat and electricity. They do not conduct any heat or electricity. A very famous example of non-metal is diamond. And this is graphite. Now, let us see the differences between metals and non-metals. First property that we are taking is luster. Metals have a shiny appearance, as I told you guys before, whereas in the case of non-metals, they don't have a metallic shine. They don't look shiny, and they don't have a shiny appearance. They are just dull in most of the cases. And second property is malleability. What do we mean by malleability? So malleability is the property of metal, that is, we can transform metal into thin sheets by hammering or by constant use of force, pressure, and so on. So basically the gist is that they can be transformed into thin metallic sheets. So metals can be beaten into thin sheets, whereas non-metals are brittle. So if we try to beat them into thin sheets, they'll break down. So they are non-malleable, and thus they cannot be beaten into thin sheets. Our third property is ductility. So what do we mean by ductility? So ductility is a property of metal that they can be drawn into thin wires. Like as I told you before, copper, we all must have seen copper wires. So it is an example of ductility. Like we can draw metals into thin wires, whereas non-metal cannot be stretched into wires. Hardness, metals are generally hard and non-brittle, whereas non-metals are usually soft. Like in most of the cases, they are soft. Now, heat and electrical conductivity. Metals are good conductor of heat and electricity, whereas non-metal, they are very bad conductors of heat and electricity. Now, properties of metal. Okay, we have discussed about this earlier. Metals in their pure state, like when they are in their purest state, like they are not, they didn't undergo any process or anything. So when they are in their pure state, they have a shining surface. Now, hardness of metal. It is hard to cut metal pieces because metals are generally hard in nature. It is their property. Malleability, metals can be beaten into thin sheets. Ductility, ability of metals to be drawn into thin wires. Now, sonorous. So, what can you think of when we say the word sonorous? So, it is somewhat related to sound. So, it means the metals that produce a sound on striking a hard surface are said to be sonorous. So most of the time you must have seen like school bells or bells like these. So this is the sonorous property of metal. Now activity 1. Here we have a setup where we have a metal wire, and now we have a burner over here, and there is this wax. So what do you think would happen in this case? In this case, gradually the wax will start to melt because metal wire is a good conductor of heat, and the heat it will be getting from here will be transformed, will be conducted from this end to this end and free end of wire, so it will eventually melt the wax. Now activity 2. Suppose here we have a sample to be tested, and here we have a setup where we have a battery, bulb and a switch. So let us suppose we have used copper in this case. So what do you think will happen? Will the bulb glow or not? In the case of copper, it will glow. So this proves that metals are good conductors of electricity. Now let us see some properties of non-metals. So non-metals have none of the physical properties associated with metals. Non-metals are brittle, as I told you earlier in the previous slides. They are generally soft solids or gases. So what do I mean by this? Like, in their original state, most of the non-metals are soft solid or they are present in the form of gases, but here bromine, it is a non-metal and it is liquid at room temperature. So this is an exception here. We can say that bromine is an exception here. Non-metals are neither malleable nor ductile, and they are bad conductors of heat and electricity. So here in this video we can see some of the metals, like properties of metals. Here are some metals and some non-metals. Like some metals are being beaten into sheet, being drawn into wire, and some non-metals are also present in the video, which shows that non-metals can be pressed easily. Now everything, in chemistry, exceptions are everywhere. So let us say chemistry is a subject of exceptions. It has so many exceptions. So now let us have a look at some exceptional cases in metals and non-metals. Metals generally have high melting and boiling point. However, in the case of cesium and gallium, they have very low melting points. So this is an exception. Cesium and gallium are exceptions to the properties of metals. We studied in earlier slides that metals are solid. Like usually they are solids. But mercury is the only metal at room temperature which is present in liquid form. And we also talked about the lustrous property of metals, whereas non-metals do not possess any luster. But in the case of iodine, it has a metallic shine, which again is an exception. Carbon is a non-metal and it exists in many different physical forms. So, as we talked earlier, that non-metals are brittle and they are generally soft solids or gases, but diamond is one of the hardest substances known. And diamond is a form of carbon. Similarly, graphite is also another form of carbon, and it surprisingly is a good conductor of electricity. So, carbon present in two forms. One is diamond, another is graphite. So, let me tell you that carbon is a non-metal. So, diamond, according to the properties of non-metal that we have studied earlier, diamond should be a soft solid or gas, but it is the hardest substance. Whereas we also studied that these are bad conductors of heat and electricity, whereas graphite, it conducts electricity. So, alkali metals like lithium, sodium and potassium, alkali metals are those there are separate groups of metals. So, one is alkali metals and it consists of lithium, sodium, potassium. So, again, these contradict the properties of metals of being hard. So, that is, they can be cut easily by knife. Now, I have a question for you. Give an example of a metal which is a liquid at room temperature. So, think about it. We have discussed this in our previous slides. So, mercury, which is an exception, is a liquid at room temperature. An example of metal which can be easily cut with a knife. So, as we discussed, alkali metals like lithium, sodium or potassium, these can be cut easily with a knife. A metal which is the best conductor of heat. Silver is the best conductor of heat, but since it is very expensive to use, therefore we use copper. But silver is the best conductor of heat. You must always remember this. Give an example of a metal which is a poor conductor of heat. So, lead. Lead, its symbol is Pb. It is a metal and it contradicts the property of metal being good conductor of heat and electricity. So, metal is a bad conductor, poor conductor of heat. So, differences now in chemical properties of metals and non-metals. So, most non-metals produce acidic oxides when dissolved in water. So let us take an example of non-metal. The non-metal that which I can think of right now is sulfur. Sulfur doesn't usually dissolve in water, so first of all let us combine it with oxygen and it forms SO2. sulfur oxide. Now, SO2, when dissolved in water, it gives H2SO3, and it is acidic in nature. Whereas most metals give rise to basic oxides. So you can remember it as like non-metals acidic, and metals plus water gives rise to basic oxides. So here let us suppose we have Na plus 2H2O. Always remember the R chemical equations should also be, balanced. So it gives rise to NaOH, as we have studied in previous chapters in acid and bases, that NaOH is the most popular base, and it releases hydrogen gas. So it proves that metals, upon dissolving in water, gives rise to basic oxide. Now, we have to explain the meaning of malleable and ductile. In the previous slides, we talked about it. So, malleable means that a metal, or let us suppose a substance, can be easily transformed either by hammering or rolling into thin sheets. Whereas ductile is that property that metal can easily be stretched into a wire when pulled. Okay, suppose we have a metal here. Let us suppose this is copper. Cu is the symbol of copper, and we try to pull it. So here it can be transformed, it can be drawn into thin wires, or aluminium sheets, silver sheets are very common example of metal sheets.